Hello. Hi everyone. Hello, hello. Hi everyone. Am I audible? If I am audible, please say yes. If I am not, then also how will you say? So if I am, just say yes. Hello everyone. Am I audible? Am I audible, guys? Just tell me. I can't see any comments here. Okay. Emmanuel says I am audible. So let's begin with the PCD now. All right. So hi everyone. Welcome to the PCD of today's Edu contest of Codeforces, and today we'll discuss the problems A to E. I am Pradyumn Kejriwal, and yeah, let's begin. But before beginning, I will tell you about our courses at TLE Eliminators. So, if you are someone trying to level up their CP, or if you are stuck at just solving one or two problems per contest, our self-paced course are all what you need. Okay. We have structured the program into four levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through recorded video lectures by experienced educators, followed by carefully curated practice problems combined with guided hints and detailed video solutions that will help you understand the why, not just the how. We believe in helping you build real intuition. Need more help? You will get instant doubt support from high rated mentors. So if you're ever stuck, you will solve that. And beyond learning, you can enjoy leaderboards, gamified progress tracking, internal contests, and PCDs like this one to keep you motivated and consistent. Pick the level that fit your goals and start learning today. And if you want to know that which level is best for you, you can just view this which level to choose video, and also you can view the syllabus of each level, and you can do that. All right. So let's begin now with problem number A. So A says there are three energy crystals numbered from 1, 2, and 3. Let us denote the energy level of the ith crystal as AI. Initially, all of them are discharged, meaning that their energy levels are equal to 0. Each crystal needs to be charged to level X, exactly X, not greater. In one action, you can increase the energy level of any one crystal by any positive amount. However, the energy crystals are synchronized with each other, so an action can only be performed if the following condition is met after. For each pair of crystals I, j, it must hold that AI is greater than or equal to aj by 2. What is the minimum number of actions required to charge all the crystals? Okay, so what you have here is a problem which says that you have initially three numbers 0, 0, 0, and you can do operations on them. Like at one point, like in one operation you can increase any number by any amount, any positive integer amount, let's say y. So if it is 0 initially, then it will become y. Okay, but you have to ensure that this AI should be greater than or equal to aj by 2 gif, should always hold. Okay, for all the indices, like for any pair of index, this AI greater than or equal to aj by 2 should hold at any given point in time. So, for example, you cannot do something like um, you increase this to 3. You cannot do this because you have the array as 300 now. And if you choose this one as AI, and sorry, not this one, if you choose this one as AI and this one as AJ, then 0 greater than equal to 3 by 2, this will not be true, right? So basically you cannot do this, like you cannot just increase it to 3. Okay, so yeah, that is what they are asking. And finally you have to convert this 000 to xxx, right? Okay, so what is the minimum operations that you need to do, right? So what will you actually do? Let us think about that. So let us see some samples. Okay, so let's say x is equal to 1. Then what you need to do is make it 1 1 1. So what you can do is, I think it is pretty obvious that you should always like just increase this 0 to 1, let's say. So it will become 0 0 1, and this is satisfied. Then let's say you increase this 0 by once more, so this will become 0 1 1, and once more you increase this 0, this will also become 1 1 1. So in 3 steps you have transformed this 0 0 0 to 1 1 1. Okay, so the answer is 3. Then let's say you want to change it to 5, like 1 1 1 to 5 5 5. So the answer is 7. So like it is pretty large, I won't simulate that, or let us just do that for the sake of it, for the sake of understanding. So let's say you have 0 0 0, and you want to convert it into 5 5 5. So on the first move, of course you can increase this 0 to a 1. Like you cannot increase to a something greater than 1, let's say 3, like, or even 2. You cannot make it 2, because if you make this 2, then if you choose this as the ai and this as the aj, then 0 less than equal to 2 by 1, sorry, 2 by 2 will not be satisfied. So you cannot change to true, you can only change to 1. So you change this to 0 0 1. Then from 0 0 1 you change it to, let's say, um, you change it to 0 1 1. Okay, then this 0, what you can change it to, you can of course change it to 1 also, but the thing is that you can change it even higher. Why? It is because um, this, like when you change it to something, let's say x, or not x because x is the number, let's say y, if you change it to, then basically this y can be bigger than 1 also, because now there is no 0 in this array. Like here in this array there were zeros, right? So that's why we could not make this element more than 1, because if we made that bigger than 1, then these zeros would have problem. Like this 0 less than equal to 2 by 2 would not satisfy. But here, after changing this to something, since we do not have any more zeros, we can actually change it to higher value. Like we can simply change it to 3 also, if you can see. So like if I change this to 3, so 3 1 1, this is also cool. Why? Because this 1 greater than equal to 3 by 2 is also satisfied, right? So 3 1 1 is possible. Then what about this one? This one you can convert to 3 3 again, because this one wants it to become 3, and then you make it 3 3 5. Like you changes 1 to this 5, and then simply you do 5 3 5 and then 5 5 5. So you can see that 7 operations have been done here. Now you might not have gotten the intuition of actually what is happening right now, so I will tell that to you. Okay, so what we have to ensure every time is that this ai should be greater than equal to aj by 2 gif, right? This must be for all the indices, or all pair of indices I comma j, right? But let me ask you that if you were to check that is it satisfied for all the indices, then would you check all of the pairs? Like let's say I give you this array 2 3 4. So if you want to check that do all these indices satisfy this condition, would you check all of the pairs? Here we have 3 into 3, which is 9 pairs. So do we need to check 9 pairs? That is the question. So what is the answer to that? Do you know? No, just check the minimum. Yes. Like just check the minimum. Like just keep aj as the minimum and ai as the maximum one. So like just keep ai as the minimum one and aj as the maximum one, so that it has the highest tendency to like not be satisfied. Like what I mean is that let's say you want to find any index which is not satisfied by this constraint. So you basically want that you want to find some index such that ai is less than aj by 2, right? So what you will try to do is you will put the smallest index here. Like you will try to make this ai the smallest, and you will try to make this aj the largest, right? And then you will check if this is satisfied or not. So let's say in this one, what you will do is you will put ai as 2 and aj as 4, right? So here, since 2 less than 2 is not true, right? So we can say that this array is satisfying the constraint. Like we don't need to check all of the pairs, we can just check the most probable ones. Like even if we put the minimum here and the maximum here, and then also the minimum is greater than the maximum by 2, then we can definitely say that um, like all of the pair of indices will satisfy our condition. Okay, like if I just check for 2 and 4, then I can be rest assured that every index is satisfied. So basically we just need to ensure that the minimum should be greater than equal to the maximum by 2 gif, right? Or what I can say from here is that the maximum has to be less than equal to 2 into minimum plus 1. Like from here I can say this thing quite simply. Okay, so till here, do you get this, guys? Do you get this part that we only need to check the minimum and the maximum? So minimum should be greater than equal to maximum by 2 gif, right? Okay, so now what we can simply say is that, let's say we have 0 0 0. Okay, so what we will try to do is we'll try to increase the 0, obviously. Now since I know that the minimum will be 0, right, after doing the operation the minimum is 0, so what can be the maximum value in this array? Like if I have the minimum value as 0, then what can I possibly have the maximum? At maximum I can only have 2 into min plus 1, that is 1. So like I can only change it to 1. If I change it to 2, then this max less than equal to 2 into min plus 1 will not satisfy it. Or basically min greater than equal to max by 2 will not satisfy, right? So I cannot change it to 2, so I'll change it to 1. Now again, if I change this 0 to something, then this 0 is the minimum, right? So it will not allow me to change it to anything more than 1, so I'll change it to 1. But now when I change this 0 to something, the minimum will become 1, right? So what I can say is that I can change this 0 to anything up to 3. I can change this 0 to anything up to 3. So like 5 or some, like, sorry, since the minimum is 1, I can change the max anything up to 2 into min plus 1, and min is 1, so 2 min plus 1 is 3, so I can change the 0 to 3. So 1 1 3 now, and again I'll change this 1 to a 3 because this one is there, so I'll change 1 3 3, and now I have this one, but now the minimum is 3, right? The minimum is 3, so now you can change it to a 7 maximum. So like you can change it to a 7. Then let's say you change this to like, so 7 3 3. Okay, then let's say you change this to a 7 because this 3 is there, so 7 7 and 3, and now you can change it to 15. But let's just assume that x is equal to 7, like for this input. Like basically in our input we had been given 7. Like just assume that we wanted to make the number 7, so what we'll do is we'll convert this 3 to a 7. We could convert this to anything from 3 to 15, but we did it to 7 because we had to make 7 only, not greater. So 777 has been become, right? But how many operations did we take to do that? Like from 0 0 0 we did 1 operation, 2 operation, 3 operation, 4 operation, and 5, then 6, and then 7, right? So to make 7, we needed 7 operations. And let's say if x was 3, okay, then basically we would have been done in this step only. Like, instead of changing this 1 to a 7, we would have changed this 1 to a 3, right? So essentially we would have taken how many operations? Like 1, 2, 3, 4, and 5 we are done. So for 3 we took 5 operations. And what about for 1? If you want to make just 1 1 1, then in this operation we can just convert this 0 to a 1 and not a 3. So we will make 1 1 1. So for for to make 1, we took 1 2 and 3 operations, right? So for 1 we took 3 operations. Now you can simply follow the pattern. Like, let's say you want to make 15. Like here, these are powers of 2 minus 1. Like, if you can see, these numbers are actually powers of 2 minus 1 actually. So basically this 1 is 2 to the power 1 minus 1, 3 is 2 to the power 2 minus 1, 7 is 2 to the power 3 minus 1, and so on. So to make 2 to the power k minus 1, I'm simply taking 2k plus 1 operations. All right. And like, you can observe it here also. So let's say we wanted to make 2 to the power 4 minus 1, that is 15. Okay. So in this case, we would have changed this 3. Why isn't it working? This is annoying. Yeah. So in this case, we want to change this 3 to a 15. And then we'll change um, this 7 to a 15. And then finally, we'll change 15, 15, and 15. So we took 2 more operations to achieve here. So we took basically 9 operations. So for 15, we took 9 operations, and this is consistent. Like for k equal to 4, we took 2k plus 1, which is 9 operations. So basically, for any power of 2 minus 1, like for 2 to the power k minus 1, our answer is just 2k plus 1, right? By the pattern. But what about some numbers which are less than 2 to the power k plus 1? Like, what about what if they are not a power of 2 minus 1? So let's say for 3 we took 5 operations, and for 7 we took 7 operations, right? But what about 4 5 and 6? What about them? What if we want to make 4 5 and 6? In that case, we can simply answer 7. Okay, like, because in 5 operations we are only able to make 3 as the maximum. Like, we greedily tried to make the maximum that we could, right? But in 5 operations we only could make 3. So to make 4 5 and 6, we can actually make 7 first. Like, instead of making 7, like here you can see that here when I made this 1 to a 7, I will not make a 7, instead I'll make a 5. Like, if I want to make 5, then I'll make a 5. So here this 5 3 3 will come, and again this 3 I'll make a 5, and this 3 also I'll make to a 5. So finally I have made this 5 5 5 instead of 7 7 7. So the operations are quite the same. Like, as of 7, the operations are same for 5 also. So for 5 also the answer is 7, for 4 also the answer is 7, and for 6 also the answer is 7. So basically the answer for 1 is 3, for 2 it is 5. Like, basically I'll extrapolate or interpolate. For 3 it is 5, for 7 it is 7, for 15 it is 9, and in between you can fill according to the higher number. So 8 to 14 also the answer is 9, and this 4 to 6 also the answer is 7, and here 2 also the answer is 5. Okay, so what you can simply do is that you can count the number of bits actually. Like, quite a nice trick to solve this Like here, if you write this 1 in binary, so it is just 0 1, right? Then if you write this 2 in binary, it is 1 0. Then 3 in binary is 1 1. So for this 1, for 1, the answer is 3. Then for 1 0 and 1 1, the answer is 5. Then for, if you write 4 to 7 numbers, then they will be 1 0 0, 1 0 1, 1 1 0, and 1 1 1, right? So for these four numbers, the answer is 7. So as you can see that the answer just depends on the number of bits. Like if we have a single bit 1, then the answer is 3. If we have 2 bits, then the answer is 5. If we have 3 bits, then the answer is 7. And let's say we have k bits, then the answer is just 2k plus 1, right? So this is the entire idea of our solution. Is it clear? Yes, you can observe 2 into number of bits plus 1. Like I also actually did the same thing. I just look at the samples and saw that this 10 to the power 9's answer is 61. And since we have 30 bits in 10 to the power 9, so I thought maybe it is something bitwise. So I counted the number of bits in each of these and just checked that this is just 2 into number of bits plus 1, right? Yes. So are you guys clear with this? Someone asked A. Uh, Tagore. Okay, you also solved A. So is there anyone who did not, like, who doesn't understand how we solved A? Yes, you can do it using while loop. You can simulate the process. That is fine, because the number of operation is just logarithmic. Like it is at max 60 operations to even make it to 10 to the power 9. So it won't give TLE. It is just 60 into number of test cases. No, it will not give TLE because the operations are very small. Like at max only 61 is the answer. So even if you spam this 10 to the power 9 many times, so in that case also 61 into 10 to the power 4 will pass comfortably. Okay, the conclusion is basically that we just observed that this AI greater than equal to aj by 2 means that the minimum value should be greater than equal to the maximum by 2. So this means that the maximum can be at max 2 into minimum plus 1. Okay. So then we saw that if we start from 0 0 0 and we try to make the maximum that we can, so from 0 maximum we can make 1. So 1 0 0. Then from this 0 also we can make 1 because there is this 0 acting as the minimum. So we can make only 1. And now we can make this 0 to a 3, because after we change this thing, the minimum will become 1. So if the minimum is 1, we can make the numbers as large as 3. So we can make this 3, and so on. If we just try to simulate this and just stop as soon as we have gotten our values, like the maximum value that we need, we'll just stop there. And I just saw the pattern. Like to get this 3, you need 5 operations. To get 7, 7 operations. And to get 15, you need 9 operations. So I observed that to get a power of 2 minus 1, you need 2k plus 1 operations. And then in between, if you want to make a number, you can just make that number instead of the higher power. Like instead of making 7, you can make 5 if you want to make 5. And that will take the same number of operations. So that's why the answer is this. And you can simply count the number of bits. So for 1, there is 1 bit, so the answer is 3. Then for 2 and 3, the answer is 5 because there are 2 bits. So in general, if you have k bits, then the answer is 2k plus 1. Okay. All right. So I'll just show you the code. The code is very easy. We just have to count the number of bits. And for that, I am using the function, inbuilt function called built-in CLZLL. So what will this will give us is the number of zeros, the number of leading zeros, CLZ, count leading zeros in the number x. So like if we have uh, 3, so 3 is just 1 1 in binary, right? So since we have 64-bit number, so we have 62 zeros here, right? So to get the number of bits, I just do it 64 minus number of leading zeros. So I will get 2, and the answer is 2 into number of bits plus 1. Okay. All right. So I think it should be clear, and I'll move on to problem B. All right. So the B says that there are n Fibonacci cubes where the side of the ith cube is equal to fi, where fi is the ith Fibonacci number, where f1 is 1, f2 is 2, and fi is f of I minus 1 plus f of I minus 2. There are also m empty boxes where ith box has a width of wi, length of li, and a height of hi. For each of the m boxes, determine whether all the cubes can fit inside that box. The cubes must be placed in the box following these rules. The cubes can only be stacked in the box such that the sides of the cubes are parallel to the side of the box. Every cube must be placed either on the bottom of the box or on the top of the other cubes in such a way that all the space below the cube is occupied. A larger cube cannot be placed on top of a smaller cube. Okay. So what they are saying is that we have n number of cubes, and a cube means a cuboid of size x by x by x, like a 3D figure with all three equal sides, equal dimensions. So yeah. So what I was saying is that you have like n cubes. The first cube size is 1, second cube size is 2, the third cube size is 3, fourth cube size is 5, then 8, then 13, and so on. So the ith cube size is f of I. F of I is the ith Fibonacci number. Okay. And now you got a, like, you have also a cuboid, or basically you have a box. You have a box of side uh, L by B by H. Okay. And you want to determine that can you fit all of these boxes, all of these cubes inside this box. Okay. So just print yes, or just print 1 if it is possible to fit all of these boxes inside this box, and print 0 if it is not possible to fit these boxes inside this box. Okay. So how can we actually do this? We can actually look at this figure right here. This one is very helpful. So here we have 5 cubes, 1 2 1 2 3 4 and 5. Okay. So first of all, just look at the like largest cube. So this cube has 8 side, right? F5 is 8. So this cube has side length of 8. All right. And we have to fit this 8 in a grid of 13 by 9 by 8. Right. So first of all, we have to fit this 8 size somehow, and then we also have to fit a 5 size also, right? So first we will put somewhere this 8 sized cube, and then we of course have to put the 5 sided cube somewhere, right? So of course, since we want to put this 8 sided cube, so all three dimensions must be at least 8 of the box, right? Like L, B, and W, or L, B, and H should be at least 8, of course, because you need to fit a cube of size 8 by 8 by 8, right? So that is one thing. Now another thing is that you also need to fit this 5 length also. So definitely whatever you do, one of the dimensions will definitely become 13. Okay, so here you can see that we put this 8 right here, and wherever you put this cube of 5 side, definitely one of the dimensions will become 13. So basically you need all the three dimensions to be at least 8, and also you need that at least one of the dimensions should be 13. Okay, so at least this much is necessary, like 8 by 8 by 13 should be there at least. Okay, so if it is not less greater than this, like let's say it is something like 9 by 9 by 9, so here even though all three are greater than 8, but still none of these are greater than 13. So we cannot actually fit the boxes. So basically, for if we have the cubes of size 1 3, sorry, 1 2 3, 5 and 8, we definitely need an 8 by 8 by 8, and plus we need also one side to be 13, right? Because we want to place an 8 and then we want to place a 5 also, so definitely it has to be at least 13. And it turns out that this is actually enough. Like if you just have an 8 by 8 by 13 size box, then you can fit in all of these 5 boxes. And you can see that right here, that's how you can fit in all of these boxes. Like what you can do, see, what you have done is, first of all, you have just fit in this box. Okay, so let us just, like, I'll just show you that how we will fit these boxes. Or let us do induction. Like what I am just saying is that if we have f1, f2 up to fn, okay, then I am claiming that at least we need a size fn into fn into fn plus fn minus 1. Like 8 by 8 by 13, fn plus fn minus 1, right? So we need at least this much, obviously, and I am claiming that this much is actually enough. So how will I fit in all of these cubes? Like how will I prove this? You can actually see it right here. Like it is obvious from this figure, but we can actually prove this also. We can prove it also by induction. Okay, and like how will we prove it by induction? Like see, what we have here is, we have a cuboid of size, see, first of all, this thing right here, it is just fn plus 1, right? Fn plus fn minus 1, so this is just f of n plus 1. So if we have a cube of size fn by fn by f of n plus 1, this is necessary and sufficient. And why is it sufficient? We can see, like let's say that this is fn plus 1, this length is fn, and this length is also fn. So what we will simply do, first of all, we want to put this cube of n size or fn size, right? So we'll put this cube right here, right? So this red shaded cube, man. Okay, so this red shaded cube right here, that is the cube of side fn, right? So out of this side length of fn plus 1, since we have used of fn side, so this length right here is f of n minus 1, right? So now we basically have this entire block of size fn by fn by f of n minus 1, and we want to fit in the cubes. Like we have already fit in the fn wala cube, right? So we want to fit in all the cubes from f1 f2 up to f of n minus 1, right? But since we assumed that to fit in this, we just need fn minus 1 by fn minus 1 by fn, right? Like in the induction proof, we assume that it is true for n minus 1, and we are proving for n, right? So we assume that it is true. So since this is true, we can simply fit all of these boxes from f1 to fn minus 1 into this one entire box of size fn by fn by fn minus 1, because we only needed fn minus 1 into fn minus 1 into fn. So definitely this box is greater than this box, right? And that is the proof. So like even if you did not get the proof of this, then don't worry. Like you, if you just got the intuition from this figure that first of all you need to fit this cube right here of size 8 by 8 by 8, so you need at least 8 by 8 by 8, and then one more you will fit in, like of size by 5 by 5 by 5. So definitely one side you need 13, like one dimension you definitely need 13. So you will place it right here, and that is enough. Like because the other cubes are very small, they can just fit in anywhere, right? So is it clear? Yes, this, like here, whatever you have said, that's what I said, right? Or did I say something else? Yes, that is true. But how this came, that I was explaining. Yes, this is true. Okay. So any doubts for B problem, guys? Or I'll just show the code. Meanwhile, you can ask your doubts and I'll address them. So LLNM, scene NM for int I equal to 0, I less than m, I less than m, I plus plus, and I taking the dimensions. So dimensions 3 length vector I take. So scene dimension of j, and then I sort this. So I want that all three of them should be at least Fibonacci of n. So basically, the smallest one, if it is at least Fibonacci of n, then obviously all of them are Fibonacci of n. And also, I need that at least one should be Fibonacci of n plus 1. So if the highest one is greater than equal to Fibonacci of n plus 1, then that is fine. So I have these two conditions. And if this is true, then it will print 1. And if it is false, then it will print 0. The C out works that way only. Okay. So yeah. Yes, exactly. So do you all have any doubt? Or are you all busy watching IPL? Now the match is over. So some, but if you're watching IPL, then that means you did not give the contest. So yeah, today B was harder than C and D. Yes, I agree. Plus plus, no doubt. Cool. So let us move ahead. How to master these type of problems? I don't know, man. Like these type. This is not type. This is just a problem. Thank you, Akash, for these words. It means a lot. Thank you. So yeah, let's move on to C. This C is pretty easy. You are given an array of n integers. In one operation, you are allowed to perform these actions. Choose a position I and make all the elements to the left of I equal to ai. That is, assign the value ai to all aj such that j is less than I. The cost of an operation is I minus 1 into a of I. Choose a position I and make all the elements to the right of I equal to ai. That is, assign the value ai to all aj. The cost of this operation is n minus I into ai. Note that the elements affected by an operation may already be equal to ai, but that doesn't change the cost. You are allowed to perform any operations, what is the minimum total cost to make all the elements of the array equal? Okay, so what we have here is we have been given an array a1, a2, a3 up to an, right? And in one operation, I can either do that I choose an ai, okay, and for all j less than I changed all aj to ai. Like basically, I can select any index I and change all of the elements to its previous, like to its left side, to a of I. And the cost of doing this is I minus 1 into ai, right? And one more thing I can do is that I can do the same thing for right. Like to the right, what I can do, basically I can choose some ai, and for all j greater than I can set aj to a of I, and this will take the cost n minus I into ai. So essentially, I can select any index, and all of the elements to the right of this I can change to that element, right? So we need to find the minimum total cost to make all the elements equal. Okay, so how do we solve this? Now, first thing to observe, like there is one observation here, that you would never do two operations of the first type. Like basically, let's say you have an array of a1, a2, a3, a4, and a5. So in this case, you would never actually perform a left operation on this. Let's say, like let's say you perform operation on this thing, the left one. So you make all of these as a3, and then let's say you do an operation on this one to make all of these a4. So in this case, this first operation was actually redundant. Like, why did you do this operation? This made no sense. Like, why would you do this operation if you had actually to replace, you had to replace a4 in later? Like eventually you just made all of the elements a4, right? a4, a4, and a4. So there was no point in changing these two elements to a3 in the first place. So of course you will never do two left operations, or basically more than one left operation you will never do. Okay, and the same for right operation. More than one right operation you will never do, right? So at maximum, what you can do, like what you will do, is one left and one right operation. Like let's say for here, for this, for example, in this test case, 7 5 5 10 9 9 4 6 10. So in this case, you can, like there are many options here. Like basically you will select any two indices. Like let's say you select this one and perform a left operation on here, and you select this one and perform right operation on this one. So basically it will, this one will change all of these numbers to a 9, and this one will change all of these numbers to a 9. Okay, so either you can do that, or you can do something like, um, perform a left operation on this one and a right operation on this one, right? So this will change all of these to 9, and all of these also to 9. But there is no point in doing that. Like what I'm saying is, there is no point in doing this operation, because this one is already 9. Okay, this is already 9, and basically the cost is what? The cost is ai into n minus I. So n minus I is just the number of elements to the right of this. So if this is ith index, then n minus I is just this number of elements. So basically your cost is proportional to the number of elements that you are changing. So if you take the less number of elements you take, the better, right? So better, what you can do is you can skip this 9. Like you can perform like this, like change all of these 3 to a 9. So change all of these to 9 and all of these to 9. That is one possibility. Or what you can do is, you can do the same thing for a 5, let's say. Like let's say for this 5, these three fives, you do the same thing, that the left of it, you make this entire thing 5, and the right of it, you make this entire thing as 5, right? So there is one possibility. And like simply you can check for all of these possibilities. And like how do you implement this actually? Like see, the entire idea here is that these groups of numbers, these 555 or this 99, they are beneficial to us because we can simply skip them. Like we don't need to perform operation on them. Like if we just do an operation on this thing left and this thing right, then we can uh, just do it. And yeah, but we have to check it for all the blocks. Like let's say there was a 1 right here, man. Let's say there was a 1 right here. So in this case, using this 1 and like changing all of these to 1 and all of these to 1 will definitely help you, because this cost, it has also AI term in it. Like the cost also has AI term in it. So as like if you choose a small AI, that is beneficial. So in this case, the answer would definitely be 9, because these 4 elements into this 1 plus these 5 elements into 1, right? So basically you just need to check all of the possible blocks. So even though in these three fives, even though in these three fives you only need to just change this 1 and these 6 elements, so only 7 elements, but the cost is 5 like per element. And in this case you have 9 elements, but the cost is 1, right? So just check for all of these blocks. But how will you check that, like for all blocks, that how much cost is there? How will you do it efficiently? Like simply what you can do is make two arrays. Like pre-compute all of the left cost and right costs. Like what I just did is that I pre-computed that if I do an operation on this one, then what is the cost? So it is 0. Then if I do an operation on this left one, then what is the cost? The cost is basically 5, because this one index into 5. Then if I do an operation on this index, a left operation, then the cost is 10, and so on. I just stored the array. Like if I do an operation on this thing, then the cost is 4. So I just stored this array. But yeah, one thing I took in mind, that let's say I have this 5553, let's say this is my array, then cost of doing this left operation, it is just 0. Like because I won't do the operation, because these all are already either equal. Okay, so the cost is 0. That's what I kept in mind. And so for every index I just computed that what are their costs for left and right operations, and then I just checked for all the blocks. Like we have one block right here of 7, then we have one block right here, then this block, and this 3 blocks. So for all the blocks I just checked that if I do the operation like this, like for these block of 5, I just checked that if I do this operation and this operation, then what is the cost. And to get these blocks, I can use two pointers. Like I will start two pointers from the zeroth index. Okay, so this is L pointer and R pointer. And like as long as this R is equal to L, like as long as this A of L equal to A of R, I will keep incrementing this R pointer. So this R has come here, right? So this R comes here, and as you can see that this means that this L to R minus 1 is one block. Okay, so I just process this block, this block, and after that I just set L to R. So I bring L ahead to R. Okay, Then again, while AR is equal to AL, I just move this pointer forward. So here it is also equal, and here also it is equal. So finally R comes here. Okay. So we know that from this current L, from this current L to R minus 1, we have a block, so we can process that. And so on, we will do until this L reaches here. So that's how we can check all of these blocks and compute the minimum answer. So is there any doubt in this? Okay, yeah. We can simply do L into AL plus n minus R into n minus R minus 1 into A of R. Um, yeah, that is fine because you would never perform an operation. Yeah, correct. I did not cheat. Actually, I used GFG code, and that was also used by some other contestants. So the CF round thought that I cheated, but I clarified that. So I must have. No, E was real. E was tough actually. Like it was pretty good. I think it was like between div 2D and div 2E of normal contests. Yeah. So, anyways, what we saw was that we can just check for all of these blocks that if we just perform the operation on left and on the right, then what is the minimum cost. So we can check that for all the blocks. So like I can just show you the code now. I'll change the code to not use the blocks. So we don't need this code. Min of like p1 into a of p1 plus n minus n minus I minus 1 into a of p2 minus 1. Okay. So yeah, this should work. I'll just try to run this. I'll need. I'll try to run this for you guys, and I think it should work fine. Okay, I'm not able to run this. I'll just run it in CF custom invocation. Yeah, it is correct. Yeah, so C is correct. So what we are just doing is we are detecting blocks, like a block of the same number. So int n c in n, take the input of n of the array A, I mean, P1 equal to 0, P2 equal to 0, and nth variable initialized to the maximum value or infinity. And while P1 is less than n, so while P2 is less than n and A of P1 equal to A of P2, I am doing P2 plus plus. Okay, so basically from P1 to P2 minus 1, we have a block, right? So I'll just relax the answer using um, this P1 into A of P1. This is the cost for the left operation, and the cost for the right operation is n minus P2 minus 1 into A of this P2 minus 1, or same as A of P1 actually, because it is a block of same numbers. And then I update this P1 to P2. So is it clear, guys? Everyone is, you are all discussing D and E, but if someone has a doubt in C, then they can ask right now. So if you all just have a doubt in C, you can ask. Like what I am, I'll just summarize. What we try to do was I showed you that it is useless to do a left operation two times, because if you do it once like this and then once like this, then all of the elements are overwritten, right? So you will only do left once and right once, right? So let's say you do left, like let's say you have this array and these numbers are already same, then you can just do left operation like this and right one like this, so that you use the minimum number of indices, because the cost is proportional to your number of elements. So if these three numbers are already same, then you don't need to change them. So you will just do this operation to make these same as these, and this operation to make these numbers same as this. And for all of these blocks, you will try to compute the answer. Anyways, since I am not getting any doubts for C, I am assuming that it is clear. It is clear. And if you have a doubt, then you can ask in the comments as well, and I'll answer. Okay. That is unfortunate, but it is pretty standard in two-pointer technique. So you might want to practice two pointers. All right. So let us move on to problem number D. This D also was pretty easy than div 2D. So yeah, we have a new semester is about to begin, and it is necessary to create a schedule for the first day. There are a total of n groups and m classrooms in the faculty. It is also known that each group has exactly 6 classes on the first day, and every class of each group takes place at the same time. Like the first class of the first class of each group has at the same time, second one at the same time, and so on. Each class must be held in a classroom, and at the same time, there cannot be classes for more than one group in the same classroom. Each classroom has its own index of at least 3 digits, and all digits of this index, except for the last two, indicate on the floor on which the classroom is located. For example, the classroom 479 is on the fourth floor, while the classroom 31415 is on the 314th floor. Between the floors, one can move by stairs. For any floor x greater than 1, one can either go to floor x minus 1 or to floor x plus 1. From the first floor, one can go only up to second, and from the last floor, one can go up to only down. The faculty's dean office has decided to create the schedule in such a way that the students move as much as possible between the floors. So they are sadist, meaning that the total number of movements between the floors across all the groups should be maximized. So the sum of the total movements for all the groups should be the maximum possible. When the students move from one floor to another floor, they take the shortest path. For example, if there are n equal to 2 groups and 4 classrooms, these 4 classrooms there are, then they can be arranged as follows. Like let's say group 1 is in 290 room and group 2 is in 293 in the for the first class. Then for second class, they all move to 47th floor. sorry, they all move to fourth floor from second floor, and group 2 also moves to fourth from second floor. Then again from fourth to second, from fourth to second, then second to fourth, second to fourth, and like so on. Like they just keep moving between second and fourth, right? So total of 20 movements between the floors. So we have to help the dean's office to make any schedule which maximizes this total distance covered by the students. Okay. So we have here um, a question which is only, like, if you just read it, it is complicated, but it is pretty easy, to be honest. Okay. For div to D at least, it is pretty easy. So what we actually can see here is that, um, let's say we have like these six classrooms. Sorry, we have six classes or six groups and 10 classrooms, and we can distribute these. Okay. So let us just draw this. Okay. Like let's say I have these four classes and two groups. So I'll just draw these four classes. I have this one class right here, or I'll draw a building. Okay. So I have this one class on second floor, 290, one more class on second floor, and one class on 479, so fourth floor, and one more class on fourth floor. Right. And I have two groups to distribute. So instead of just like explaining this, I will explain one more better example. So let's say I have one classroom on the first floor, one on the third floor, one on the fifth floor, and one on the seventh floor. Okay. So I have four classrooms right here, and I have only two groups. Okay. So just think about this for a moment, that how will you solve this if you have four classrooms like this and you have two groups? So what will you arrange? Tell me, guys, how will you arrange them? If you have four classrooms, 1357 floor, and two groups to arrange, so how will you arrange them? It is pretty simple, guys. Just think of it. Extreme end class. Okay, so one group you will give that, they will study at this group. Like the first group will study in the class 1. So for the first group, they will first class 1, then class 7, then class 1, then class 7, then class 1, then class 7. But what about the second group? You are saying 3535 3535 and 5353. So you are saying that for group 1 this thing, and for group 2 this thing. So you are just using these two classes. So instead of like, these have only two floor distance, right? You are making them zigzag in these two floors. So instead of doing that, currently is doing same thing for 1 7. Like for the first group, you can do in 1 7 1 7 1 7 1 7, and for second group you can place them in 7 1 7 1 7 1, and so on. So all of these students will have to zigzag between six floors. So six floor, six floor, six floor, six floor, and six floor, and so on. So you had same like right idea but the wrong numbers. So yeah, for two groups you can simply do this, that zigzag, make them zigzag between 1 7, then 7 1, then 1 7. And like, since you have two classes right here, you can um, make two groups travel between them. But then what if you have a third group as well? What if you have three groups? So in this case, you will of course, like, first two groups you will rotate in 1 7, right? But in third group, what will you do? Like, because these 1 and 7 are occupied by the groups 1 and 2 always. So what will you do? So for the third group, you can only do something like keep them in 3 and then 5, then 3, then 5, then 3, and then 5, right? And let's say you have one more group, fourth group, then you will keep them in 5 3, 5 3, 5 3, like this. So this is the answer. Okay, so for the first groups you will try to make them in the extreme end, and for second group the same thing but in the opposite order. Like if the first group is at first floor in the first period, then second group will at seventh floor at the first period, and so on. You can do like this. Yes. So yeah, this is the essentially the optimal way to approach this problem. So like I'll take one more example. Like let's say you have um, 8 classrooms from 1 to 8. So 1, 2, 3, 4, or let's say you have 6 classrooms. I have a small diagram. So you have 6 classrooms, and you have, let's assume you have 5 groups. Okay. So for the first group, you will make them zigzag between the first and sixth floors. Okay. So first floor, then sixth floor, then first floor, then sixth floor, first floor, sixth floor. Okay. Then for second group, you will do the opposite. So the sixth floor, first floor, sixth floor, first floor, sixth floor, first floor. Then for third and fourth group, like okay, now first and sixth are gone. Now you will use this 2 and 5. Okay. So for the third group, you will do 2 5, 2 5, and 2 5. And for the fourth group, you will do 5 2, 5 2, 5 2. Then the last group, the fifth group, this 2 and 5 also gone. So 2 and 5 also gone. Now only 3 and 4 are remaining. So you will alternate between 3 and 4, and so on. Right? And that is equal to, that is the optimal approach. What if n is equal to m? Then also you will do the same thing. For example, you have 4 floors. Let's say you have floor 1, 2, 3, and floor 1, 2, 3, and 4, and you have 4 groups. Then you will like alternate 1 between 1 and 4, 2 between 4 and 1, the group 3 between 2 and 3, and the group 4 between 3 and 2. Right, like this. If n is equal to m and n is odd, so in that case one classroom will be fixed. 5 4 3 2 1. So if you put like for the classroom, for the class 1 you will do 1 5, class 2 you will do 2 4, for third one you will do um sorry, not what am I doing, for the class 2 you will do 5 1, for the class 3 you will do 2 4, for the class 4 you will do 4 2, and for the class 5 they will only be in 3. Okay. So this is 1 5 1 5 1 5 1 5 1 5, 5 1 5 1 5 1 5 1, 4 2 4 2, sorry, 2 4 2 4 2 4, 4 2 4 2 4 2, and this is 3 3 3 3 3. Okay, Aniket, this is the optimal approach. Like you can actually think of it like you have been given m points, and you want to like connect n by 2 pairs of points to maximize the total length. So the optimal way is to connect these, then to connect these, to connect these, right? That is the optimal approach. Like because you want the maximum overlap. So the maximum overlap comes with this approach only. Like take the first and last, then second and second last, and third last, and so on. Okay. And the implementation, like for the implementation you can actually just sort the array Okay, like if you just sort the array, let's say you sort this array, then it will be 290, 293, 478, 479. So basically the second floors are, like, basically in your array you will have something like second floor, fourth floor, right? And then you can just pair them up like this and just print them. All right. So for the implementation, I'll, like, it is very clever. Like, I just implement it like this, that I just first took in the array A, I sorted the array A, okay. Then for all the groups, for n groups, for int I equal to 0, I less than I plus plus, I have to print six numbers, right? So for the ith group, I print I by 2 and m minus, like, basically the complement of I by 2, like I by 2 from the beginning and I by 2 from the ending for the ith group, right? And I alternate between them. So first I print this, then I print this, then I print this, then I print this, then I print this, and then I print this. But this is for even I, and for odd I have to first print this one, then print this one, then print this one, then print this one. So this I plus j and 1, like if I plus j is odd, then I am printing this one, and if I plus j is even, then I'm printing this one. So this will take care of that. Like, you can simply try to write on this, and you will see that how it is working. Okay, so this is a quite a nice implementation. All right, so I'll give you guys 1 minute to look at it. All right, so I think, can we divide by 100 and sort? If you do that, then you can't print, right? You have to print the numbers as well. Like, um, in the output, you have to print the room numbers. So if you divide by 100, you'll only get the floor number, you won't get the room number. So to do that, you would have to make a pair and then sort. So instead of doing that, just do what I did. Okay, Harshvardhan. Saturn, where to learn C++? Like, there are many YouTube channels or many resources. Like, there is this website called Learn CPP, which I use. Like, I am actually right now learning in depth C++. So I am learning from here, but this is like starting from the beginning only. So you can learn from here if you prefer text material, or if you prefer YouTube or videos, then you can just search on YouTube and watch the popular ones. I can't take the name, but you can watch the popular ones. All right. PBKS one. I thought RCB one. Like, I didn't watch the match, but I thought RCB one. Yeah, right. Anyways, so let us move on to the problem E. Given a string S that consists of only the first three letters of the alphabet, meaning each character of the string is either A, B, or C. Okay, before we discuss this, I would like to tell you that it is a very nice problem. I like this problem, and it has quite a bit of thinking. So, just a brief notice. So, if you are stuck at solving like 12 or 1300 problems, then you probably shouldn't try this. Like, this would probably be pretty tough for you. Okay, C list is not opening right now, but what I am saying is that this E problem is pretty tough to think about, but not really after you have heard the solution. So if you want, you can stay, but if you want, you can skip this as well. Like if your target is like reaching 1400 or something, then you can skip this for now. And when you are expert or something, or like a specialist, then you can watch this. But of course, I won't disallow you to watch this, and probably you will understand also that how it worked. But anyways, so let us start with this. Given a string s that consists only of the first three letters of the alphabet, that is a, b, or c. Also given are q operations that need to be performed on the string. In each operation, two letters x and y from the set of the first three letters of the alphabet are provided, and for each operation you can do either change any occurrence of the letter x in the string s to the letter y, like change any x to y, or you can do nothing, you can skip the operation. The goal is to perform all the operations in the given order in such a way that the string s becomes minimal, lexicographically minimal. And they have given the definition of lexicographically minimal. Okay, so in the problem they have said that we have basically we have been given a string which has only a, b, and c. So let's say we have a, b, c, a, b, d, a, sorry, not d, a, b, c, a, b, b, a. Okay, a string like this, and they have given us like q operations. Okay, and in each operation they have given us two letters, like let's say they have given us ab, or they have given us ca, for example. So what they are saying is that we can basically traverse through these operations, and we can try to, like, either we can do nothing, like either we can discard this operation, or we can choose to replace any character with the given character. So like if this is x and this is y, we can replace x with y, any one occurrence of x with y. So let's say we can replace a with b, so we can replace any of these a's with a b, right? And our goal is to make this string minimal lexicographically. So that means that in dictionary order it should be minimum. Okay, so how do we actually solve this? Now the first thing to ask yourself is that why would you actually increase something? Like let's say you have this operation a comma b, right? Then why would you change any a to a b? Why? Like at this character you had the minimum thing and you changed it to something else. That is pretty much useless, because you want the minimum thing, right? You want a, and if already there was a, then of course why would you change it? So if you have an operation called ab or ac, you won't actually do it, like you will skip that definitely. Okay, but what about the operation like bc or something? What about this operation bc? If they have given a bc operation, will you ever do this? Just tell me this one, guys, that will you ever perform bc? Because in this case as well, you are increasing this b to a c, right? Like if you replace any b with a c, then definitely you are increasing the string. So will you ever do that? Thank you, Mark. If ca is there, and then only, exactly. So if there is a ca also, like let's say we have a list of queries a, b, a, c, um, b, c, and ca, and our string is something like ba, ab. Okay, so so first of all we see this, we don't do anything. Then see this, we don't do anything. Then we see bc. Then we think to ourselves that should I increase this b to a c? Should I increase this? And actually the answer is yes, I should increase this, because I have a ca as well after this. Since I have this ca, I can convert this C to an A afterwards. So it will become AAAB, right? And that is the only case in which we are increasing an element. Like if we have been given BC, then we'll use BC if only we have CA. Okay, right? So this thing is very clear. And all right. So now, like, how do we think of actually this? Like, let me give you an intuition. Let me think of how to give an intuition for this. Like, what I thought was for this problem was that since you want this string, like, let's say this was the input string, ABCA, BBA. Okay. Since you want this input string to be the minimum, that means that when, let's say, you iterate over the string from left to right, so first of all you need this thing to be the minimum at any cost. Like, if at any cost you are able to decrease this A, okay, then definitely you will decrease it. But obviously you cannot decrease this A is the minimum that you can do. So of course this A is the minimum, so you will go ahead. This is already A, so you will go ahead. Then you come up with this B. Okay. So if it is possible to convert this B to an A somehow, then definitely you will do that. Like, even if that messes up entire thing right here, like, even if converting this B to A uses the operations that we cannot use right here anymore. Like, let's say we if we did not do B to A right here, then we could do B to A right here, right? But we don't care about that, like, because we want the minimal string lexicographically. That means that our entire priority is this thing right here, because this one already we have minimized. So first we have to minimize this one, this is A, then we have to ensure that this is minimal. So if there is any way to convert this B to an A, then we will definitely do that. Like, we'll definitely try to convert this B to an A. So what ways can be there? Like, one way is that there is a BA operation somewhere in the list of operations. So in this list of operations that we have been given, so like this list, if there's a BA somewhere in this list, then we can definitely use that BA. Like, when we reach that BA, we will change this B. Okay. So essentially, we are using this BA to fix this B right here. Okay. So we will use that BA and make it an A. Right. But what if there are no BAs? What if there are no BAs? Is there any other way? Yes, there is one more way, that you can actually change this B to a C and then C to an A. Okay. So if you have both BC and CA in your query list, then you can use both of them on this index and basically convert this B to an A. Right. But there is one more condition to this, that this CA must come after this BC, right? In the list of operations, the CA the CA must come after the BC. Like, if it comes before the BC, like the first CA and then BC, then basically when we are just traversing through these queries, how will we actually convert this B to an A? Like, we cannot use these to convert this B to an A, because first we need to convert this B to a C and then C to an A. But in our question, we are supposed to iterate down these queries, and either we can use the query, like either we can use the operation instantly, or we can skip it, so we can never use it in the future, right? So if this C2A comes before this B2C, we cannot use this. So BC has to come before CA, and if it does, then we can use both of those operations on this index right here to convert this into A. Okay. So now we have done this B to A, and let's say if it was not possible, like, even this BA was not there, and this B to C and C2A was not there, then you definitely cannot convert this B to an A. Okay. Now let's move ahead to C. Like let's say you have a C now. Okay. So if you have a C now, then either you can convert it to A. Like preferably, you want that it becomes an A, right? At any cost. So either you should have a C to A, right? Either a C to A should have, or you should have a C to B, and then somewhere you should have a B to A. Like not necessarily that they should be contiguous. It is not necessary that they should be contiguous, but they have to be in this order. Like C to B should come first, and then B to A should come. Okay. So C to B and B to A. So if either C to A is there, then you will use this C to A. And if this C to B is there and then B to A is there, then you will use these two ones, like these two on this index to convert this C to an A. And if both of these are not there, then you will try to convert this C to a B. And how will you convert this C to a B? Just by using a C to B operation. So if you have a C to B in your array, like in this list of queries, which you have not already used, see, as soon as you use an operation, let's say C to A, then you have to delete it. Like you cannot use it anymore, right? So if you have a C to B that has not been used yet, then you can use it and make it a B. Now you might be thinking, what about C to A and then A to B? Well, if you have a C to A, then of course you will just make A, right? So this makes no sense. Like if you want to make C to B, if you want to make C to B, then you will definitely use an operation for C to B, right? So this is the entire solution. Like um, you have to use these operations and just do it. But now the main question is how to implement this in like linear time or in time limit. Like you cannot actually iterate over all these queries, right? Like you cannot actually do something um, like you have this B right here. So you have this B right here. So search for a query of B comma A. So if you search for it, it will take O of Q time, and O of Q into N will definitely not work, right? So you have to implement it efficiently. Like how do we actually do this efficiently? You can simply store the frequency of every operation that you have. Like um, how many times this B to A occurs, how many times B to C occurs, how many times C to B occurs, and so on. So you can just check that do you have any operations of C to A left. So if you have the frequency of C to A is positive, that is not equal to 0, then you will just decrement it by 1. Like um, decrement it by 1, stating that you have used it on this index right here, right? So that will sort the single operations, the C to A ones. But what about the double operations? Like how will you keep track of whether you have B to C and then C to A? Like with just frequency array, like how will you keep track that whether or not you have a B to C and then you have a C to A? How will you keep track of that? Like one thing that you might say, that if the frequency of B to C is positive and if the frequency of C to A is positive, then you might say that we have a B to C to A. Like you might say this, but this is not correct. Why? Because because it might happen that C to A comes before the B to C in our query list, so we cannot actually use these. So even though the frequency of C to A and the frequency of B to C was positive, we don't have a B to C to A. So how do we actually keep track of that? So to do that, we will just create one more variable to keep track of how many BCA we have. Like in this case, for example, let's say we want to count the number of BCA. So here we have a BC and here we have a CA. So we have one BCA like this. Then we have a BC and here we have a CA. So we have one more BCA. Okay, and we have this one more BC which is unpaired. So basically, what I'll store is the frequency of BC to be 1 and the BCA counter to be 2. So, like in this case, for this case, my BCA counter would be 2 and my BC would be 1. And what about the other ones? See, we care about BCA also, and we also care about CBA. Like when we want to convert this C to an A, we were trying to convert C to B and B to A as well, right? So we also care about the CBA ones. The CBA ones also we care about. So we will count that as well. So here we have one CB and then we have a BA. So we have one CBA and we only have one. So we have one CBA. Okay. So yeah, this BA. Wait. Okay. So we have one BA. Then we have this BC has been used up in this CA. So we won't count that. Then we have this CB, which is used up in this BA as well. Sorry, with this BA. So these are used. Then we have this CA here, right here. So we'll count that. And yeah, like in this way, we will keep the count of everything. Like we will keep the count of BCA, we'll keep the count of BC, we'll keep the count of CBA. Like we'll keep the count of all of these 6 pairs, uh, BA, BC, AB, AC, and CA, CB. So we'll keep count of these 6 pairs, and this one also. But do note that there is one thing here in implementation. There is one caveat here that let's say that at some point, you want to convert C to an A. Okay, so there were two ways of doing this, right? Either you could directly convert C to an A, or you could convert C to a B to an A. Okay, so let's say that the frequency of CBA, like the CBA variable, is also equal to 0, and the CA variable is also equal to 0. Okay, then you might say that we cannot convert this C to an A. So now let us try to convert this C to a B. Okay, but the thing is that you also have this BCA. Like you also have a counter for this BCA also. Okay, so if your BCA counter is, let's say, 1, that means you have one BCA. So that means you have one BC, one B2C, which is unused, and one C2A as well, which is unused. So since you have a C2A hidden in this BCA, you can actually use this right here. Sorry, not here. You can use this right here to convert your C to an A. So in that case, the frequency of BCA will get decremented, but this B2C pair is now free to use. So the frequency of BC will get incremented. Okay. So yeah, that is the entire logic here. So same thing for C2A, like same for C2A, and also the same for B2C as well. B2C, B2A. Yeah. So if you want to convert B to A, and if you don't have BCA, BCA is 0, and BA is also equal to 0. But if you have some CBA, CBA is equal to 1, let's say, then you will definitely use this, and you will break this CBA into CB and into BA, and you will use this BA. You will use this BA right here, and you will just increment the frequency of this CB also, because you can use this CB in the future. Okay. So this is the entire solution. Like why AB and AC? Yeah, true. Like we don't need to store the count of AB and AC. So if I have both BCA and BA, I will prefer BA. Yes, exactly, because this BCA, actually, if I have both BCA and BA, I'll prefer BA. That is true. And why is that? Or good question. A BCA and BA. So the thing is that this BCA consists of B to C, and C to A, and BA consists of B to A. So either you can use up these two, or you can use up this one. So which one you should use up? One. So now you might argue that this BA might be used in CBA. Like one reason of not using this B2A is that you might argue that what if in the future we get a CBA, like we don't have a CBA because we used a B2A right here. So here B2A is used. That is one argument. But I say that you will just use the CA at that point, right? Like if you have an option of BCA and BA, that means you have CA in your hands. So if this comes, situation comes, then at that point you will just use CA, and right now you can just use BA, right? So that's why you will prefer BA over BCA if you have both of them. Okay. And like maybe it might be correct that you can choose any one of them, but I'm not sure. Like probably it is safer to choose BA only, because there is no harm in doing that. Can a similar problem with 26 characters be solved in similar time complexity? Um, I'll answer that later. Wait. If there exists a BCA and a CA, come just make them BCA and make the frequency -1. Yes. So like when you are iterating through the queries, if there is a BC, like let's say you come across a CA. If you come across a CA and there was some BC which was before it, then you will decrement the frequency of BC, and you will increment the frequency of BCA. And if there was not a BC before the CA, like until now, if the frequency of BC is 0, then you will simply increment the frequency of CA. I'll show the code, don't worry. Only frequency won't work since we need sequence too. I think your doubts is solved. Okay, so I'll go through the code. But yeah, the logic is pretty clear, right? To all. Everyone just tell me, is the logic clear? Meanwhile, I'll just check that did my solution get hacked or something. So until now it is not hacked. Nice. Okay. So I'll show the code. Yeah, so implementation wise, I have just like I have done it pretty neatly, to be honest. Like what I have done here is that I have made a frequency array of 9 length. Like this stores the frequency of all 9 pairs, like um, AA, AB, AC, BA, BB, BC, and CA, CB, and CC. Of course, this BB, CC, and AA will definitely be 0 only, but I have just included them because it is very easy to implement. So to this AA, I am storing in index 0, this AB in index 1, this AC in index 2, and so on. Then 3, 4. So actually, why I have index like this? Because I can simply find out that, let's say, like if I take an input from the console, then I can very easily find out the index. Like let's say if I want to find out the index of BA, it is 3, right? So I will just do um, this B minus A into 3 plus A minus A. Like in general, if I have XY, then the formula for its index is just X minus A into 3 plus Y minus A. So if you try to like put in these characters in this XY formula, you will get this. So that's why I have made this frequency array of 9 length. Okay. And I also have a counter for CBA and also for BCA. So a string is C in S. Then I'm iterating over the queries to increment my counts. So character A and B, C in A and B, and my index is 3 into a minus a plus b minus a. Okay, so if t is equal to ba, that means if the current input is ba, then I can pair it up with a cb, right? Like I want to keep track of cba, no? Like I want to keep track of cba. So if I have a ba right now, and if I also had a cb earlier, I can just pair them up. So if the frequency of, like if the current letter is ba, and if the frequency of cb is not equal to 0, then I'll decrement it, and I'll increment the cba, and otherwise I'll just increment the ba, right? And the same thing I'll check for ca also. So if I already have bc, then I increment my bca and decrement my bc, because I have paired this bc with this ca. And like I also don't increment the ca because I have used it in this bca. And if I don't use it in the bca, I'll increment it. And in general case, like if it is anything else, then I'll increment it directly, right? So by now I just have, sorry, like until, like using this for loop, I have counted that how many things do I have of each thing, right? And some of you might be thinking that how I'm writing like this, like how is fr of bc correct syntax? Like how am I writing fr of bc? Actually, I have defined one enum right here. So this is basically equivalent to writing a equal to 0, ab equal to 1, ac equal to 2, ba equal to 1, sorry, b equal to 3, bb equal to 4. So if you write like this, it just assigns basically these uh, characters the value. Like this starts from 0, then 1, then 2, then 3, and so on. So I just wrote this right here to um, so that my implementation is a bit easy. Okay. All right, so I have just kept track of the frequencies of CBA, BCA, and also the other doublets. Now I increment, like I just iterate through a string, okay, and greedily just try to minimize each character. So for int I equal to 0, I less than I plus plus. If s of I equal to a, then it is already minimized. I don't need to do anything, so I continue. Else if s of I equal to b, so I'll try to make it a. So if I have ba, then I'll decrement this ba, and s of I I'll set to a, like from b to a. So I have used this one ba, and I'll do this. Otherwise, if I have a cba, then actually I can break it. So I'll break it into cba and ba. I'll break it into cba and ba. So cba minus minus and cb plus plus, because the cb is now free, and I use this ba to convert the b to an a. And if I have bca, then I'll just use bca and convert this b to an a, right? So basically, here first I'm trying to use a ba. Like if I have a ba, then I'm using ba, and if I can get a ba by breaking, then I'm using a ba. And if I cannot get a ba by any chance, then only I'm using a bca. Okay. Then if the character is c, like I just handle the a and b case. If it is a, then continue. If it is b, then try to make it a. And if it is c, then first try to make it a. So if I have ca, then I'll use this ca as of I equal to a. If I have bca, so if I have ca right here, so I'll break it. So bca minus minus and bc plus plus, and s of I equal to a, so I use ca in there. And if I have cba, then I'll use it. So cba minus minus, s of I equal to a. And if I don't have any of these three, that means I cannot convert the c to an a. So I can convert, like try to convert the c to a b. So if I have cb, if fr of cb, then I decrement it and I convert it into a b. And just do this for all the indices greedily, because we want to minimize lexicographically. And finally, just print the string s. Okay. I have a query if there is a b somewhere in the string, and if we are doing bc and then ca operation, but if there are some ba operation left and less ca operations are there, There might be a case where future CA maybe could turn into A, but we already use the BC and CA. We can't able to do it right now. See, what you are saying is that I'll just try to understand what you are saying right now. If there's a B somewhere in the string, okay, so if we use BCA, okay, so you are saying that if we are using BCA, but we still had BA, then we should use BA. Yes, it is true. We should use BA first and then we should use BCA. That's what I have done in my code. Okay, you might be replying to something that I said, like, yeah, true. We should first use BA and then we should try to use BCA, because if we use BCA, then we are unnecessarily wasting the CA operation. So if in the future if we get C, then we might get messed up. Right. Thanks, Aditya. BA first, then CBA leaks to BA, then BCA. Yes, correct. So do you guys get this? Finally, do you guys have you guys understood how to solve this problem? All right. So how do you guys like this problem? What did you think of its rating? What do you think it is rated? Just a little curious. What is enum? Like, see, when I define this enum like this, when I write this, it is basically equivalent to writing int a is equal to 0, int ab equal to 1, int ac equal to 2, and so on. So this is equivalent to writing this. Okay, like just writing this thing is equivalent to writing this. But actually, like in the low level, if you ask me, it doesn't actually create these variables. It like okay, actually, yeah, it does create these variables. Yeah, it is equivalent to just creating int a, int ab, int ac, and so on. So instead of writing this, if you just write this thing, int ba is equal to 3, int bb is equal to 4, and so on. If you write this, then it is the same thing, but this is faster to write, so I just use this. And yeah, in the order that you specify right here, like in the order that you write right here, in that order it will assign the numbers. So to, as you can see, to a it has assigned 0 right here, then to ab assigned 1, and so on. And you can actually change the default value. So like you can do a equal to 5, so it will start with 5 now. Assign 5 to this, then 6 to this, and so on. So yeah, how do you practice? Like currently what I'm doing is, I'll show you. Like let's say I want to solve the problems for rating of 1900. So what I'm doing is I just go to problem set and I enter the difficulty of 1900 and I solve the problems by number of solves, and then I go to the second page and then I start solving from here. And why do I do like this? This is because the first page is like, the first page means that so many solves are there, so probably the problem is easier than 1900. So that's why I solved from page number 2. And like the more solves there are, that means the problem is more relevant. Like here this is 38k solves, so definitely it is not 1900 really, right? It is inflated. So yeah, that is how I practice usually. And on CSES also I have done some problems, not some, actually many problems I have done, as you can see right here. So yeah, you can also practice like this and keep giving contest and solve them. Sorry. All right. So, any other queries? Anyone? Order of topic practice. Like whatever topics you have studied. Actually, whatever they have given in the order, that is fine. Like first introductory, and then sorting, searching, then DP. That is normally what is taught in some like courses or on YouTube channels. So this is fine. Actually, you can try graph and then trees and then range queries. But in trees, it uses range queries also. So it might be wise to learn range queries before trees. Or you can leave those problems which use range queries. Like after this problem, I think every problem uses range queries except for these four. Okay, so you can skip those. Thanks, Tanam Ahmed. How to become better at proving the solution? That I don't know. Like even I sometimes don't prove my solutions. Like today, if I tell you, um, I did not prove my solution for this A and this B. Like for this A also I did not prove. For this B also I did not prove. This C1 I like there was no proof in this. It was just brute force. But yeah, for this A and B I did not prove. So either your intuition should be strong. You should be confident about your intuition, or you should be able to prove. That's the thing. Thank you, Red, and entire context for greedy only. Well, yeah, like true. These were not really challenging. Like they were greedy, basically ad hoc, you might say. F was also easy. Yeah, some people solved F in my friends as well. They got like 60 rank, and in Div 2 they got I think 25 or something rank. Yeah, 25th rank. So F was not that easy, but yeah, if a second year student is able to do it, then except for Dominator, then it should be doable. Like not as hard as regular Div 2F. Yeah. Anyways, so let's end this now. If you guys don't have any more problems, and I'll just go ahead and look at the IPL highlights. I am first year. Oh, great. If you are already doing this much CP, then it is quite nice. Keep growing. All right. So, bye everyone. I hope you all like the PCD. If you did not like, then you can just comment that what you should, what you think I should improve, and hate comments are not encouraged. Okay. All right. Bye bye.